Welcome to another broadcast from mindyourhealthcast.com. I'm sure, again, you've been anxiously awaiting for the next episode of what might be going on in my world. It's not Wayne's world, it's my world. Don's world. Today, I have been perusing for some time and periodically taking the time to dig backward into the history of, as I've said, health and medicine. And it came to me that certain discoveries that I've made in my archaeological digs and uncovering of material sitting on dusty shelves and so forth have arrived at three significant discoveries that to me made a major change in how I viewed health and sickness and how I approach working with people, although they may not always understand because it may be too complicated and people don't like to be challenged too much, so we want to keep it as simple as possible. So I'm calling this my three greatest health discoveries, or almost everything I was taught and thought seemed to be wrong. And it's true when it comes to health. You know, I grew up, like most people, thinking that science was getting better and better. They were uncovering more and more, that these were very meticulous, honest people who wanted to get at the real truth of how things worked and what they were, and I decided that I wanted to join this elite group and make use of the latest knowledge and discoveries. And I started out in the health field thinking in that direction. Along the way, bit by bit, pieces of information came along that seemed to be a bit of a contradiction to the commonly held positions about a lot of things when it came to health and wellness. You know, we had been taught, for example, that in the realm of vitamins, you know, vitamins are vitamins. It doesn't make any difference whether we've synthesized them in the lab and hence in our manufacturing process, or whether it's come from plants and so forth. It doesn't really make any difference. A vitamin's a vitamin. And so it seemed somewhat reasonable. But as time went on, I started digging and really understanding a lot. It became apparent to me that that wasn't quite factual. But I thought, well, you know, it's really just an honest mistake from the scientific community, because after all, they're seekers of truth, and seekers of truth are going to go where truth leads them, no matter whether popular or unpopular. Boy, was I surprised. And as you've probably heard in some of my broadcasts, I've found out that it's anything but the truth that we get. And to find the truth is extremely difficult because in many cases, certain powers have gone to great lengths to cover up the truth or even access to any knowledge of it. And just recently, again, I found out that some very important books that had been written back along the way were extremely difficult to find because it appears that the families did not want to release the book. And my suspicion, you know, although unconfirmed, is that at some point along the way the books were too damaging to make easy access, and therefore it was to the advantage of the people who maintained the copyrights after the person who had written the book was gone from this world. It was to their advantage to accept a few funds to kind of keep them under wrap. And I've discovered that recently with about at least four books that I know of, and that in fact, I know of a fifth that was difficult to get to. And I think that unfortunately, many times when money is at stake, some interesting things can develop as a consequence of that. So at any rate, I'm just going to mention the 3 things that I discovered, but we're not going to cover those today. We don't really have time to do all of them. So we're going to talk about one of those 3, and somewhere along the way we'll get to the other 2. I don't like to do this in a series because even though they're all interrelated, in a sense, they're pretty much standalone because there's enough material for any one of them to probably do a series from. But we don't have time for that, and people kind of get tired of listening to something if it drags out too long, so that's why we've abbreviated more. Hopefully people will follow it through, because if you start what I'm talking about and you don't really follow it through to the end, more often than not, you're really not going to grasp what it was I was talking about. But basically what I'm talking about is truth related to health, and of course you're going to hear that term thrown around a lot. In fact, probably so much so that it really doesn't have as much meaning as it did at one time. And sometimes the truth is as little as we can know up to this point, because there many times are deeper layers that will somewhat modify what it is that it appears to be as the truth. Okay, so the 3 big things that I discovered are related to, 1, the real nature of germs. We're always hearing about germs, and we probably see, if we watch any TV at all, handfuls and handfuls of commercials related something to do with germs. And we're, of course, admonished that we have to take immunizations against germs. And we're admonished that we have to use soap dispensers that have germicides in it so we can get rid of those germs. And so it's become a big household word. Now, it's interesting because when I was young, we didn't hear so much about it. I mean, we heard it mentioned some, but there was not the obsession. And of course, you remember that I came into this world, and my early years were in a society free of antibiotics and all the germicides, etc., etc. And so, you know, surprisingly, we lived through it without all those antibiotics and without all that knowledge. And so it's quite interesting to me how it's made to be such an important part of life. Anyhow, that's the one that we're going to really be talking about. But the second one is nutrition and health, the real story. Now, you know, we're told all kinds of things, and probably all you have to do is get on the internet and you'll find that there's probably 10,000 diets out there, and maybe a slight exaggeration, but it's pretty close to the truth. Every year there's at least 2, 3, 4, 5 new diets come out, and each one claiming to be the right one. So at some point we'll get into that in more detail, but there's a tremendous cover-up related to diet and health. And we can point out, and we will point out, when all of this came about and why it came about. And the third big one that was a big eye-opener to me, and that I would say was a discovery which really changed my whole viewpoint on a lot of things, is what I call the body quantum. I'm using that term because it's the title of a book written by Dr. Fred Alan Wolf, a quantum physicist, which I've mentioned to you about before. I've appreciated all the work and writing that he has done, and it's pretty eye-opening as far as understanding the nature of life and our bodies and the world. And in that particular book, he goes into more detail about how principles of quantum physics work in our body. And so I found that whole idea of quantum physics and the human body and the nature of the world to be very, very useful as far as understanding how things happen, and of course had a lot to do with the mind-body, which we've talked about, the relationship between the placebo concept and the nocebo concept and the mind-body medicine. So we've hit on pieces of that, but I don't think that we've really focused in as much as it could be. So those two, the nutrition and health, the real story, and the body quantum, are some future broadcast, I'm not sure exactly when, but I don't like to, as I say, crowd it all together anymore. And sometimes you need some time to think about what I've already told you before we jump into some deeper water along the way. And by the time we get into the body quantum, we've gotten into some pretty deep water. If you really can grasp or get an understanding of the quantum concept, not that it's not able to be understood, but it causes a rethink. In fact, all three of these are going to cause a rethink when we get down to it. Truth, of course, as I say, is kind of interesting. I ran across, it looked like a road sign, the big green ones with the big white lettering you see along the road, but on it said, truth, the only thing that people don't believe. It sometimes seems that people would prefer to believe a lie, and I think the reason why is that lies are more user-friendly. And they're kind of aimed at telling you something you already want to know, like, well, it doesn't make any difference what you eat, just so you get some food in, that's what's important, you know. Well, that's a lie. I mean, it's partially true in the sense you have to put some food in, but the question is all food the same? And of course the answer is no, but we're led to believe that that's not accurate, so that therefore is a lie. And so it's funny, but people would much prefer to believe the lie, as I say, because I think it caters to what they already would like to believe in the first place, and so it's easier to sell. Goethe, you've probably heard of him, Johann Wolfgang von Goethe, the German author who actually used many more words in his writing than Shakespeare did, and Shakespeare was credited with having written or used the most English words in his writing, which was approximately 25,000, but Goethe, who wrote in German, actually wrote about 50,000 different words in his writings. So he was quite an educated individual, but he had a comment to make about truth, and I thought it was pretty good, and it's pretty appropriate for today. Truth has to be repeated constantly because error also is being preached all the time, and not just by a few, but by the multitude. In the press and encyclopedias, in schools and universities, everywhere error holds sway. Feeling happily and comfortable is in the knowledge of having majority on its side. In other words, error is always in the majority, it seems, and so everyone thinks, well, you know, it's kind of crazy to think that because almost everyone thinks this. And so they get very reluctant to be willing to embrace something that is not commonly held by everyone. And of course, as I say, when I was young, I kind of had the feeling that the scientific community was in search of truth, and that when they found truth, that they would relate truth to the public. But what I found was that along the way, there was something called this religion of science, or scientism, whereby these are the core, fundamental, basic evangelists of science. Even though they don't practice science, they, under the cloak of science, say that anything that they don't embrace as being true is not true. And even in their research, they already have decided what can't be true, so they're only looking for what will tend to support what they already would like to believe. And so that isn't true science, and I found out there's a lot of that out there. And then, of course, I found that in many cases, in order to make a lot of profit, many scientists were willing to produce false information when they received the right price tag for it. And it's unfortunate because, as I say, we grew up believing that science was objective and that it was willing to stand on the truth no matter where it led. And that is, the truth uncovered error, then we received the truth and we could then discard the error. And I kind of thought that way when I was young, and I was in admiration of the scientific community. And I'm not to say today there aren't some good scientists, because there are, but there's an awful lot of the ones you hear the most from, which are of the religion of scientism. And those, I think, kind of, they operate in a different world. And I was disappointed when I really ultimately came to the conclusion that sometimes they could be bought off if the money was right. And so it always then got down to a matter of how much, not what is truth or fact. So we're going to talk a little bit about germs, and what I'm going to introduce was kind of disturbing and shocking to me when I first got into it, because I had been taught all of the traditional idea about bacteria and germs and these bad bacteria in most cases. Now, they did talk about some friendly bacteria being in the bowel tract, but apart from that, there were all this bad bacteria out there, and they would attack you and they would make you sick, etc., etc. And so, at some point on one of my German study trips, I became acquainted with some of the deeper things that the Germans knew that I hadn't been taught here. One, of course, was homotoxicology, which I've mentioned before. And if you are rusty on it or a bit cloudy, I would go back. There is a broadcast called Homotoxicology, and get a better understanding of it, because it was actually through homotoxicology that opened the door for me and started me thinking. And so I started on this big pursuit to find out what I could find out. And of course, ultimately, it led me back all the way to Pasteur and to Jenner and so forth, and a new name popped up which I had never been introduced to. And I had not seen any quotations or citations or any reference to this individual or any research that he did. And just being introduced to the name alone became a tremendous eye-opener. The same thing happened when you hear about all of Darwin's work, and all of a sudden you are introduced to an individual by the name of Lamarck. And you think, wow, why haven't I not heard about him? And I'm not going to get into that now, but it's the antithesis of Darwin, and you might find it interesting. And he was a French researcher and scientist. And anyhow, Antoine Béchamp came to the forefront, and that started me on a whole new trek. And so what I found out is that Pasteur and Béchamp were contemporary, and up to that point there was no true germ theory of disease. Now notice that the operative there is theory, because still today you hear the comment about the germ theory of disease, and that's what it is. It's a theory. I believe, of course, the germ theory as postulated today is incorrect, and I have many reasons for believing that, and I think ultimately both logic and research is consistent with that being accurate. There's some glitches, and the glitches are understandable in light of where our world has gone today. For example, before I even get into all that, I'm sure everybody has heard about this flesh-eating bacterial form. And I bring that up because the real story behind that is one that you'll probably not run into. It's very difficult to even get any information on it, and it's certainly not ever been on the evening news. The real story is that it's a streptococcal bacterial form. Now, it actually is a strep form that became ill. Now, I know you're wondering, what is he talking about? Well, you understand that when we talk about germs, we kind of throw out this big, broad, comprehensive grouping of things. So we call bacterial forms germs, We call fungal and yeast forms germs, and we call viruses germs. So we're talking about three totally different realms, but we kind of group them all together under germs. Well, bacteria are, in fact, one-celled living organisms. It's interesting about life forms that life forms are kind of self-protective, and they don't like to die, actually, and they don't like to be put out of the way any more than you or I do. We're not real happy if somebody tries to wipe us out, and neither are they. Now, even though they may be one little cell, they are, in fact, a living organism that has a life cycle. They do, in fact, take in nutrients. They do, in fact, give off byproducts, and they do reproduce. They also have preferences as to the type of food that they have adapted to. Now, notice that I used the term adapted to because in a minute you'll see what that really means. But the fact is that they live and carry out a function, and I'm going to tell you that my findings are that the function they carry out is a part of the scavenger function of nature. Now, you know that when something, for example, some living organism like an animal or a bird or a human dies or is killed in some way, that body immediately goes into a process of disintegration. The disintegration means that everything literally starts to fall apart. Everything was held together by a life force that kept it going, but once that life force is no longer there, everything starts to come apart. That which was holding it in place to be what it is or was is no longer present, so it just starts to come apart. So the protein begins to break down into amino acids, which also come apart, and in the process of coming apart, they begin to emit toxic materials called ptomaines. And I'm sure most of you have heard that if you eat bad meat that has ptomaine in it, that it could be toxic and potentially even fatal. So ptomaine is a toxin that's a byproduct of the disintegration of protein. And that's what happens to your body. All the protein in it starts to fall apart. And in the process, it rots, literally. And the rotting process, as I say, produces ptomaines, which the two major ones in the group are cadaverine and putrescine, which are interesting names. And so the smell of a rotting corpse is what you're getting from the protein disintegrating or coming apart. It's releasing all of that because there are sulfur compounds, and one of the byproducts of protein breakdown is ammonia, which actually is produced in your body when we have amino acids that are worn out and come apart. They release ammonia. Ammonia is a part of it because ammonia is a nitrogen compound, and that's what the core of amino acids are nitrogen. The whole nitrogen family, actually. When I say family, meaning all the combinations that nitrogen makes with other atoms. So consequently, and I should mention that the body has to get rid of that because it's extremely toxic, the ammonia is. And so the liver has a special cycle called the urea cycle where it actually step by step takes ammonia molecules and converts them to urea molecules, which then go back into the blood and are released in the urine. But the body has to keep doing that all the time because as we build the body up, we're using new amino acids, and sometimes we have to convert one to another, which is called transamination, which is done by the liver. And there are times then when they're worn out and they break apart, or the liver breaks them apart. In any case, the byproduct is ammonia. And so that ammonia has to be removed from the body or we would die from ammonia poisoning. And the brain, of course, has a secondary cycle because it's critical that the brain not be poisoned by ammonia because it's extremely sensitive to it. And so it has another cycle of its own, plus the big cycle by the liver in general, because of some of the stuff being produced in the brain by the breakdown of proteins. Then that ammonia has to be cleared pretty fast. And so there is that small cycle that takes up the ammonia from one amino acid, converts it into another, from L-glutamic acid to L-glutamine, which goes back in the blood, goes to the kidneys strip the ammonia off, convert it back to L-glutamic acid, which goes back to the brain. So all these things are working to keep that from happening. But at any rate, when the body starts to disintegrate, it's toxic, poisonous, and nature wants to clean up the mess. So how do they do that? Well, they do it with bacterial forms and fungal forms that break the body down back to dust, literally. And so you have the big first level are the buzzards and the vultures. They come down and eat most of it, or wild animals as the case might be, and they clean up the muscles and the organs and all of that. So then you're down to the skeletal structure and the few of the debris. So along comes ants and other things that eventually clean up the skeleton down to the bare skeleton, and after enough time the skeleton itself will disintegrate into dust. And so it all goes back to the dust, and so we have this cleanup cycle. Now in our bowel tract we have a lot of bacteria because they do the same thing. They clean up toxic material that can accumulate in the bowel tract, and that's their function. And out of those, they actually can build some special nutrients or vitamins for the body from this debris that's coming through the bowel tract. And in some of the mucous membrane areas, you have some bacterial forms, some that can also clean up. In the throat you have it, in the ear you have it, in the lungs you have it. These are all natural bacteria to the body. Now, getting back to this strep thing, what happened is that the throat always has strep. I mean, at any given time, you can take a swab from the throat and you can culture strep out of the throat. Now, the question is then, if strep is the cause of the problem, then why don't you have a big inflamed throat and from this strep and have to be taking something all the time? Well, the fact is that that is not the case. The strep is there, and if you take a course in microbiology or bacteriology, one of the things you will find is there's a page that says normal flora of the body. So besides the friendly bacteria in the bowel tract, there is in the ears a bacterial form most often called Haemophilus influenzae. There's one in the nose called Staphylococcus aureus. There's one in the throat, Streptococcus. On the skin is Staphylococcus albus, and so forth. So throughout the whole body, there's these normal forms that live there, and they're friendly. They work with us. They're synergists. They like the food. Remember I said earlier about the preference for food. They like the food that's available, and they in turn then clean up our debris, so they help keep us clean. At the same time, we're feeding them. So it's symbiotic. Now, I ask, and some of you may have heard me say it already, I asked a researcher from a major pharmaceutical, I said, well, you know, strep lives in the throat all the time. And he says, that's correct. And I said, well, if it lives there all the time, why would it suddenly become pathogenic and attack us, and therefore we'd have strep throat? Well, we don't know. Well, the reason they don't know is, of course, is because it never does. It never attacks you because that's not its job. Its job is just to clean up the debris that's being given off in our body. And the more the debris there is, the more of the organism there is to clean it up. So they replicate faster and produce more because there's a bigger food supply. When the food supply becomes less, then the colony slows back down and becomes fewer. As they die off, they don't replicate because they don't need it. There's not enough food. So it's kind of self-regulating. Now, what can happen, though, is if you take the assumption that the bacteria attack you, and therefore you have to kill them, and that's how you get better, That was the germ theory of disease developed by Pasteur. And when you go back and look at that, and you really think it out, it doesn't make sense. If in fact they're there all the time, why would they suddenly attack you? I mean, did they get mad at you or what? Maybe you weren't giving them enough food, so they give you a bite so you produce more food. The fact is, they are passive in the sense that they break down the poisons that are being emitted by your body. So if you're emitting less poison, there's less of them. If you're emitting more poison, there's more of them. So what is the benefit in killing them? Well, that's a good question. So when you take the antibiotic, what really happens? Well, two things. One is you do kill some bacteria. That's true. Until, as all living organisms do, if you keep trying to kill me, I have to adapt or die, which humans have to do the same thing. So it adapts by changing its form, and it's genetic, and therefore it changes maybe what it prefers for food, and maybe it no longer prefers the food that's in the throat, it prefers something else, because with a genetic change, you have altered the lifestyle of that organism. Okay, so why do you feel better? Well, you feel better because, number one, the body immune system has initiated an inflammatory response to get rid of some poison. The bacterial colony has increased to eat up the poison that you're getting rid of, and therefore you don't feel good, because when that inflammation is initiated, you get redness, heat, swelling, and pain, which I've mentioned many times, and sometimes fever. That's the body immune system trying to take care of a problem. When you go back to homotoxicology, you find out that's the case, that's what's going on. So the antibiotic will turn all that off. Okay, so, and if they give you an anti-fever, the drug, aspirin or Tylenol or any of those, Motrin that they give you, if you take any of those, that turns off the fever response and helps to shut down the immune system. So once you shut down the immune system, you feel better. But the question is, have you solved the issue that the body was trying to get rid of? And the answer is no. And if you do that, later the body will try to get rid of it again, and then you shut it down again, and at some point the says, oh, wow, this is awful, that you keep having this tonsillitis, which they say is a disease. It's not, it's an inflammation of the tonsils. So then what do? Well, I think we better remove your tonsils. Okay, since they're lymph nodes and you take them out, of course, you don't feel that anymore, although that's not always true, because there's actually 5 pairs of tonsils, and at most they can only get at 2 of them. But you're less likely to have the sore throat as we now know it. We'd have a different type of sore throat from some of the other tonsils that they were unable to get to. So what happened with this flesh-eating bacteria, which is what I'm getting back to, by excessive antibiotic therapy, some of these strep says, hey, if we don't change, we're going to all be dead. And so they altered their genetic structure so that they wouldn't be bothered by the antibiotics, but something else happened. It also ended up that their digestive system, which is pretty rudimentary in a bacterial form of one cell, changed the enzyme. And so instead of being an enzyme that breaks down hyaline tissue to get at the poisons in the throat, it now developed an enzyme that breaks down fascia. And because our body is just loaded with fascia, guess what? It just starts traveling through the body, digesting all this fascia. And it's called necrotizing fasciitis, which means it kills the fascia and digests it. Now, is it attacking you? Well, no, it's just eating. And since you have all this food out on the table, it's just going to eat and gorge itself and bring more buddies along by replicating faster. And pretty soon you got a major problem because it's already antibiotic resistant, which is why it mutated in the first place. Now, I don't know if it makes sense to you. So that's part of the big problem, is that we have created more issues by trying to kill off the bacteria who were doing nothing more than keeping you clean in the first place. And of course, the less toxins you have, the less you have need of it. But that goes into one of the other things that we'll be talking about later, is the advent of all the toxins. So therefore, medicine is not going to tell you that they created this flesh-eating bacteria, but in fact that's where it came from. Now, I know you've probably never thought, or at least a lot of you haven't, I have mentioned it before, but it may have gone right over your head, that these bacterial forms are able to get sick. I don't know if you consider that bacteria can get sick, but they can. And how do they get sick? Either by antibiotics or some other chemical toxin to them, or by viruses. Now, they normally resist viruses if they're healthy, but if we make them sick by keep trying to kill them, then they get weakened, then they can pick up a virus. And what is a virus? A piece of DNA or RNA, which then can incorporate into the bacterial form RNA and DNA and create a mutated form of bacteria. So now we have the treatment causing a worse problem than what was going on originally, which was simply the body had inflamed and the bacteria was eating up the byproduct of what we were trying to get rid of. Now, I don't know if that's making any sense to you, but it gets more complicated than that. First of all, you need to remember that there's two types of bacterial forms. In general, those that can live in your body as a friend, and those that live in the soil as a friend. Those that live in the soil as a friend clean up the soil. Now, getting back to what I said earlier, everything in nature over the millennia have developed a cleanup process to keep the nature clean. They have their own cleanup process. And so all of the carrion, all of these flesh-eating things, all of these bacterial forms, all these fungal forms, they clean up. You know, when you see a rotting log and you see fungus growing on it, it's destroying what's left of that log to take it back to dust. So whether it's our body, whether it's an animal, whether it's a tree or vegetation or whatever it is, there is a cycle. I've mentioned before, very little known, that actually a plant that grows in poor soil and is very sick actually produces a chemical that attracts insects to come and eat it up. So the insects are the bacteria, in a sense, or at least one of those, that gets rid of a plant. Once it's sick, it's no longer needed. Now, what do? Well, we create a pesticide. We grow a sick plant. We create a pesticide to kill the pests that want to come and eat it, and then we sell you the sick plant to eat for your health. Sounds kind of interesting. So I'm hoping it's beginning to make sense. Now, there's so much to tell you about this that, as I say, it could be 3 sessions, and I'm just trying to catch your attention about this bacterial thing. So the bacteria can get sick, and I will tell you that it's known that the cholera bacteria that you actually get sick from the byproduct of, that cholera has been made sick with the virus and mutated, and that's the one that makes you sick. I will tell you that the soil bacteria, Clostridium botulism, has been made sick and now produces a byproduct that's neurotoxic in our system. So you remember now, when you have a living form inside of you, the byproduct of metabolism of that organism has to not be toxic. So strep is not toxic to us, staph is not toxic to us, Haemophilus, pneumococcus, Klebsiella, E. coli, all those are not, unless we do something to poison it and change its genetic code that it behaves differently. In other words, it's like a Frankenstein monster of the bacterial world. Now, I hope that's getting through to you. I don't know if it is, and it's complex. Now, it's interesting. There's a book that was published way back in 1949. Again, not easy to find. In fact, my copy came from Australia. It's called Bacteria Incorporated. in which is told the story of New York's $500,000 bedbug, which is interesting, and I'm not even going to get into that part of it. It was written by an author whose name is Cash Asher, A-S-H-E-R. If you search on the internet, you'll probably be able to find it. And it's not a big, long book. I think it probably has about 100, well, not even 100 pages maybe. But it actually, I guess maybe it was more of a booklet, but it was called About Bacteria. And it's interesting because what I've just been telling you has been known, but has really been kept away from you. I'm just going to read you a tiny bit from it because I see our time has gone already, and we're already running over. And it's called Chapter 2, Do Germs Cause Disease? If we, the patients of 300,000 doctors in America, now that's back in 1949, could see laboratory experiments as clearly as we see the pictures on a movie screen, many of our beliefs would quickly fall apart. Now, I'm not sure of that. Sometimes people don't believe what they see. More often, they see what they believe. Through the growth of bacteria in various cultures, we would witness the modification of these living organisms by way of adjustment to existing conditions. Just kind of what I was talking about. We would see them change their structure, color, and size. We would see innocent forms metamorph into the spirochete pallida, I'll get it right yet, pallida of syphilis, of Typhus bacillus identified with typhoid, blah, blah, blah. It required the passing of several decades for biologists to recognize that germs are capable of remarkable transformation from one type to another. Now, that concept is called pleomorphism, which means having many forms or shapes. If you visualize a mouse slowly changing into an opossum, you would get an idea of what happens among inhabitants of the microscopic world. So we're talking still about living organisms, just very small. But this phenomena of bacterial life was first demonstrated around 1910 by Dr. E.C. Rosenau of the Mayo Biological Laboratories. The results of his studies are set forth in the Journal of Infectious Diseases for 1914, Volume 14, pages 1 to 32, exclusive. Now here, we're talking way back in 1910. This was known. Rosenau demonstrated through a series of experiments lasting for several months that simple bacterial forms like streptococci, or pus germs they used to be called, could be made to assume all the characteristics of pneumococci, which are the ones in the lungs, pneumonia germs, simply by feeding them on pneumonia virus and making other minor modifications of their environment. And when Rosenau reversed the procedure and fed pneumonia germs on pus, they quickly changed into streptococci. Many other experiments were carried on, and in every instance, the germs, regardless of type, changed into other types when their food and environment were altered. Other bacteriologists who followed the pioneering of Rosenau have verified his findings. Among these were two New York researchers who reported transforming cocci, the round berry-shaped type of bacteria, into bacilli, the long rod-shaped species. And then he goes on to talk more about the experiments, and it says, denied their exclusive type of food, moved from their natural habitat, and fed on other kinds of food, they quickly change into the forms native to their new surroundings. And ultimately what they're saying is, since bacteria ignore living tissue, now that was the point I wanted to get to, because they don't bother living tissue, they only work on sick tissue or sick material. Since bacteria ignore living tissue and hunger only for lifeless matter, the researchers are pointing to their excreta as the poisons or viruses that produce disease and death. That's what they're thinking. And it's true. If you take a bacterial form that's natural to the ground, because nature cleans up the ground with bacterial forms, gets rid of manure and all these different things that contaminate the earth, dying plants, and so forth. And they do the same thing in the human body. But if you take one from the ground, it may be that the exotoxins, which is the byproducts of metabolism of the one in the ground, could be toxic to us, which is the case in the wrong kind of botulism. It paralyzes our nervous system, or the wrong kind of Clostridium tetani, which is what we call tetanus. Those are also ones that their exotoxins are toxic to our body. They don't attack you, it's just that their byproducts are toxic. And so what they really do is they clean everything up. So there's ample knowledge. Now this isn't all, but I say all that because when you go back to Béchamp that I mentioned, see, that's some of the stuff he discovered. There were things living in us that changed their form as our body got dirtier. Now he kind of thought, and he didn't believe we were attacked by germs as Pasteur did, and that's the problem. He believed that the change of the body environment caused these to change their form that lived in our blood and in our tissue, and at some point he thought they might become pathogenic. But again, that was a hypothesis. I believe they never become pathogenic. I think they go from beginning to end. In their most primitive form, they look like a viral particle that you have to have a high-powered microscope. But as they change into cocci, they change into rod forms. They eventually change into a fungal form, and we don't have time to get into the ramifications, and it probably gets too complex anyhow. But there is a final form called mucoracemoses that helps in finally taking the body back to the dust, and those forms have been found in mummies from Egypt and in corpses and so forth, and it all makes sense. It's just a part of the natural cycle of things, and at no time, in my mind, do they ever attack you. What kills you are the poisons that we get into our body that messes up our terrain. But that's a subject of another discussion. But I'm saying all this to say, if you really want to open up, just look what that would do to the antibiotic market, which sells tons every year, if you realized that they were not needed to be killed. What needs to be done is to clean up your environment. And see, this was researched before, even in London Homeopathic Hospital. They took people that had, quote, strep throat. They cultured a huge amount of strep in the throat. They didn't give them any antibiotics. They just gave them a correct homeopathic that helped the body get through the inflammatory process it was doing. And in a few days, they went back and cultured, and the strep was back down to normal without ever at any time killing any strep. So to me, if you start gathering all the evidence from all over that has been kept back because once there was a big antibiotic market, there's no motivation to say, well, we don't really need those antibiotics. I mean, after all they're doing is cleaning us up. What we need to do is help you get the poisons out of your body, and then you won't have all this happening. But at any rate, that's not likely to happen anytime soon, getting back to science. So here we know way back in 1910 they knew it. Béchamp did his work way back in the 1800s. But the medical profession loved the idea of Pasteur, one germ, one disease, one cure. Made a real simple thing to sell the public, and it worked. It became a massive industry. And now, of course, some of the most sophisticated antibiotics out there are selling for 20 bucks a pill, which is not bad. It may cost them a nickel to make, but 20 bucks is pretty good profit. However, if we did that in the natural health field, you know, they would say, oh, that's unconscionable that you would make that kind of money. You pay $1 for it and you charge $100 for it. Oh, that's terrible. I mean, you guys are frauds. But here, pharmaceuticals can do it every day and it's fine. Anyhow, we're done. We're past the end of our time. My producer is giving me that signal like, shut your mouth. So, here we go. We're finished for today. Be sure and go to our website and look at the things. And do look for this paper called Bacteria Inc. I'm not saying I agree with everything in it, but the research I liked was already done way back in 1910, apart from Béchamp. In fact, Béchamp is not even mentioned in this writing at all. I'm not even sure if they were familiar with his work because it was suppressed for years And it's only now in recent years gained some notoriety among certain groups of people who were looking for the truth. Anyhow, I'll be looking forward to being back with you again. So you have a good day, and until the next broadcast, be healthy.